Um, my name's Adam Smith. I'm a faculty member in computer science here, and also by courtesy in electrical and computer engineering, and also in CDS. My work largely looks at some technical dimensions to privacy. So it's quite a different flavor of question from the ones we've been talking about so far today. And specifically, I've been looking at privacy in statistical data sets, in statistical databases, where there's this kind of fundamental tension between accuracy and the kinds of privacy goals people articulate. So consider, as an example, the problem faced by the United States Census. They collect data from all of us all the time through the decennial census, but also through many other surveys about our income and all sorts of more obviously sensitive aspects of our lives. And they collect all this data and they want to make it as available as possible to researchers, to policymakers, to whoever actually wants it, for public benefit. So they're trying to make it as widely available and as many aspects of it available as possible, subject to some responsibility on their part to maintain the confidentiality of individual respondents. Okay, and so there's this sort of basic tension between trying to share as much as possible, but also provide some notion of privacy. And this problem is not really unique to the census. It's shared by many different kind of organizations that manage sensitive information on behalf of people. So that's in context from public health, companies like of the kinds we've been hearing about, Meta and Twitter and former Twitter and Google and all these, but also educational data, like BU itself collects lots of information about its students. And so my research is really on trying to understand this broad area and put it on very rigorous foundations and try and quantify as much as possible what we mean by these goals and what trade-offs are necessary among them. Okay, so just to kind of, as a starting point, imagine one of the things we might want to do is take a data set that we want to share. And the sort of obvious first thing to try is to just remove the obviously identifying information, addresses, social security numbers, phone numbers, that kind of thing. And that might be a problem simply because, maybe we're actually interested in exactly where people live. If we're studying, spread of a disease, we might need to know what dorm room exactly you are in, not just that you live in Boston. But it's also problematic because it doesn't work. So here's a photograph. Some of you have seen this example before that I've helpfully grayed out the face of the subject in this photograph. But most of you recognize the individual reasonably quickly, perhaps with a pang of nostalgia, because there's all these other elements in this photograph other than the face that you can connect to other things about the world, right? There aren't that many people who stand behind that lectern. Among them, even fewer have dark skin. That narrows it down very quickly. Okay? And this is a toy example, but it's actually in some ways representative of the problem we face when we're trying to sort of anonymize data or somehow remove identifying features, that pretty much everything is an identifying feature. Anything that's useful it can be an identifying feature. And there are lots of examples of this. Case in point, someone looked at face blurring and just tried training a facial recognition algorithm on blurred faces, and it actually does pretty well with standard blurring algorithms. There are studies that have re-identified, figured out how you can sort of, with some reasonable confidence on large fraction of people, predict their last name from their genetic sequence. I can talk about why that is. It's not that complicated. There are a bunch of examples, but basically everything is an identifier, and potential attackers have access to other types of information, other data sets and stuff. And so it's really hard to kind of understand exactly the best way. These sort of straightforward attempts at anonymization run into serious problems. Okay, so there is, at this point, my animations got totally mixed up, but there's at this point, this is a sort of a burgeoning and blossoming field of research there's work on sort of trying to, as I said, definitions, trying to quantify exactly what we mean by privacy, what we're trying to articulate the goals formally in a way that could be sort of where we can assess how well we're doing, designing algorithms that satisfy these criteria, and for, you know, either just fundamental algorithmic design ideas or adapting those things to specific applications. So there's like a lot of work on, well, the kinds of summary statistics that you might publish at the US Census. That's sort of one big area. Another big area is training statistical models and machine learning models and doing statistical inference in kind of principled and accurate ways. There's also work on just breaking stuff. And it turns out that this is, in addition to just being like fun, is you know, very valuable as a kind of way to inform our decisions and understand what can go wrong. And there's connections to all sorts of other areas of science and policy and law that I won't have time to talk about. So I think I overshot my time. I was going to like tell you like one more sort of technical idea that comes up in this work, but I think I'll have to stop there. Thank you very much. Ah, no, I wasn't supposed to do that. Sorry. There we go.
See if it still works.
There you go.